Alright, class. Let's just talk real quick about the things that you are going to have memorized for the memorization quiz. So looking there, this is on our chapter with limits. The three conditions for a function to be continuous at C. Anybody have one of those three? Continuous at C. Here.
F of A exists.
In this case, it's going to be C, so we'll say f of C must exist. That's good. So remember, the function has to exist there. The limit has to exist there, so the limit of f of x as x approaches C exists. So for a function to be continuous, you have to have a dot right there. You can have an open circle or an asymptote. You actually have to be approaching the same thing from both sides. And third one. That's why we're having to memorize this. Close, yes. F of C must equal the limit of f of x as x approaches C. Those two things have to equal each other. The function has to exist at that point. The limit has to exist at that point. You can't be having behavior difference from left to right. And the thing that the function approaches from left to right is the actual place where the function is defined. All right. Next item. What are the three situations which the limit doesn't exist? So this actually, I think we talked about even before the continuity here.
If there's this continuity.
Yeah. Nope, you're thinking about the three situations in which the derivative doesn't exist.
Oh.
Behavior
Yeah.
differs from left and right.
Is that the same thing as oscillation, or is that?
Oh, no, it's not. Behavior different. Oscillating behavior.
Okay.
And unbounded behavior. No particular order. As a side note, we have there the two special trig limits. The limit as x approaches 0 of sine x over x. You just need to have that memorized. That's one. The book talked about that, proved this using the squeeze theorem. And the other one, the limit of 1 minus cosine x over x as x approaches 0 is 0.
So it's 1 and 0.
1 and 0, just make sure you remember which one's which.
Wow.
Okay? We don't know everything on this chart yet, so on Thursday I'm not going to expect you to have all of it memorized, but the parts of it that we have discussed, I do expect you to realize. Alright? So slope of the secant line, m secant, that's delta y over delta x. That's just rise over run. Item 2, definition of the derivative using delta x. So that's f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. That's the limit of the difference quotient. For weird, strange reasons, mathematicians don't always use delta x right there. Sometimes they just use h.
H of x.
No, just h. They just use h. So item 3 says definition of the derivative using h. I literally want you to write h in every location that there is a delta x here. So it's this. It's the limit as h approaches 0 of f of x plus h minus f of x all over h. That is the definition of the derivative using h. I don't want some little small thing like the fact that they're using an h to, in one textbook to cause you from missing the concept. Like, oh, it's always delta x or whatever. So And then there is an alternate form of the derivative. That's f prime at c. So the derivative at a particular point is this. The limit of f of x minus f of c over x minus c. Think about that for a second. What does this really resemble? F of x minus f of c over x minus c.
So, should the first one?
It does resemble the first one, and which harkens back to what Nick is saying here. Y2 minus y1 over x2 minus x1. Which that's what all of this is based on, is the slope formula, right? Oh, sorry, I forgot to put. So the only question is, so this makes it really obvious that we're talking about the slope. It makes it really obvious that we're dealing with what happens as x gets closer and closer to c. Where x is some other point or whatever, c is the point that I want to find the slope of the tangent line. So if you remember, the whole activity that we did was find an x over here and find that secant line, find that slope, then move a little bit closer, find that slope, then move a little bit closer and find that slope. You see what I'm saying? So as x approaches c, find the slope of the difference quotient. The three situation in which a derivative doesn't exist. Always with the three. Think good news, bad news, things come in threes. Alright? This is what we talked about, I think, last week maybe, or maybe yesterday. That was last week. One of them was, where the derivative does not exist. That is a discontinuity. If there's discontinuity, if the function breaks, then you can't find the derivative there. A sharp turn. And the problem is with that is that the trend on the secant lines rather is going to be different from the left from the right. And the third situation, see if I can draw this out of you. So the derivative is the slope. So a time when the derivative doesn't exist is when the slope doesn't exist. What's the situation when you have a slope that does not exist? What's undefined?
If it's a vertical.
Yes. So if your tangent line is vertical, so we'll say vertical tangent line. Four notations for the derivative. Alright, see what you all remember. What is one of them? Class? Are they already on your paper?
Delta y over delta x.
Okay, delta y over delta x, not really.
That's not right.
That is like the change in y over change in, and it's always some like measurable amount, like up and over. However, and that's Greek. However, if you go here and write dy over dx, what dy and dx stand for is a differential amount, which means an infinitely small amount up and an infinitely small amount to the right. And that's, if we were looking at a curve, we're like, I want this point right here, and I want to go up an infinitesimally small amount and to the right infinitesimally small amount, and then figure out what that slope is. Okay? F prime, y prime, I haven't really used that one very much, but that is a notation, and d over dx with that bracket, and then your function on the inside.
So is there any difference of f prime x and y prime?
Yes, one of them has an f and then parentheses with the x inside, and the other one has a y.
Wow.
You asked. But probably a little bit closer. Is there any hidden meanings between this? No. It's literally, I could write equals, 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 equals. F prime of x equals y prime equals dy over dx equals derivative with respect to x of f of x. Those are all notations for the same thing. The derivative. Alright, speaking of the derivative, yesterday we talked about the derivative of constants. Who has an awesome memory and knows what the derivative of a constant is?
It's
Zero, yeah. We also did just sort of revisiting on the product rule, or not the product rule, of the power rule, where you pop down, power down. We did a revisiting of the sum and difference rule. We did talked about the constant multiple rule, where you have some constant in front of another number. And then we dealt with second, third, fourth, nth derivatives, right? Take the derivative of a derivative, then you take the derivative of that if you want to. We also started talking about this. What's the derivative of sine? And we did some local linearization here. So we drew the sine curve, and then we did local lines, and we plotted it. It turns out the derivative of sine is?
Cosine.
Cosine. So now, as a table, what I'd like for you to do is to do that same activity. I'd like for you to draw cosine, okay, and do local linearization on that to try to find derivative of sine. I'm taking all bets. Anybody have a prediction on what that is? Hector, what do you think the derivative of cosine is? He thinks it's tangent. Other,
I think it's sine.
sine.
Yes.
Anybody else want to throw their hat into the ring, prediction-wise? Rosa? She thinks it's 3. Emily, what do you think?
I was gonna agree with Ivan on the sign.
Stephanie? Sine of 2.
No,
okay.
sine.
Oh,
Just
sine, okay. I'm gonna make you commit here, Chloe. It doesn't have to be one of those.
Yes. You can also guess it's like 0 or something.
Yes, 0.
Yeah, that's a good answer.
Nick? Secant.
Oh.
Oh,
Fancy.
Jeremy?
Jeremy, I probably already know, so.
Do you already know?
No, I don't.
Do you just have like apparent like intuition?
Intuition, as long as you probably can just tell by looking at it.
Maybe negative side.
Oh.
Cody? Let it begin. It's about last October. After we do this activity,
Okay,
we'll begin some
let
problems.
me get my.
How's that sound?
Yeah, I just didn't know what I was doing.
Yeah, we didn't. Like I said, we're gonna do some problems, so we'll definitely take care of that.
Yeah, the back one's starting to
So we're doing that.
Yeah, but I don't know if that's
Yeah, so we have to make 2 charts.
So you help getting started. There's a cosine function. Remember, cosine starts high, ends high, and in the middle he's at his low. Pi over 2, 3 pi over 2, he's crossing the x-axis.
This is your idea. Just say, what we should do. I'm sick of the last time.
We've got something that starts at 0, ends at 0, and in the middle it's 0. So, drawing these vertically is a good idea, so that way you can just drop it down so the X lines up. You get it?
Yes.
Alright.
Sorry, it looks like that.
Talk to me what's going on in this first region here, Rosa.
What?
What's going on in this first region here? This
Going
first-
down.
Okay,
So
and until maybe right about here.
yeah, and then
That's-
it's,
It's lowest low right there. So lowest low right there, so it goes down. Then it looks like kind of starts to be shallow and more shallow, right?
Mhm.
So about right up here. Nick, talk to me about this region right over here. Going positive up until about right here, maybe, right? Steepest point, and then it kind of comes back to 0. So steepest point, we'll go with 1.
Oh, it just dropped here.
What does that look like, class?
It's like negative signs.
Now it looks like a negative sign. You already had it drawn. Did you already have it drawn at the point when you guessed?
Yeah.
You already had it drawn. didn't you?
you monster.
What?
You
I didn't got that.
So negative sign is dy over dx.
Changing that.
Alright. There is also a list. I'm not giving it to you this week because it's not part of this week's memorization quiz, but it'll be part of next week's memorization quiz. A list of the derivative rules. And one of those rules is the derivative of sine is cosine, and the derivative of cosine is
Negative sign.
negative sine.
What's the derivative of negative sign?
Good question.
Wouldn't it just be cosine?
Wouldn't it just be cosine? Well, nope.
Oh, okay.
This big circle, is it sine?
Oh, sorry. No. The derivative,
It goes to cosine.
it's the derivative of negative 1. It's just a constant multiple. Negative 1 times sine, so it's negative 1 times the derivative of sine. What's the derivative of sine?
Cosine.
Cosine. So it's negative cosine.
Oh, makes sense.
So, ask your question.
What's the derivative of negative cosine?
I don't know, figure out what's the derivative of negative cosine.
Oh, it's gonna be negative. Oh, no, not
So,
negative.
the constant multiple rule is if you have a constant times anything, you just carry the constant down. So negative,
And then
and then what's the derivative of cosine?
negative sign.
Negative.
Oh, so
sine.
it's gonna be positive sign.
So yes, it is a big circle, bigger than what you thought. It's a 4-part, not a 3-part. Okay. Can we trace it through? So it's so you got sine, then cosine, then negative sine, then negative cosine, then sine.
Nice.
So, okay, and we'll look at some things with motion, probably at the end of this chapter, that kind of they're gonna reinforce this. You'll find that there are, there's a relationship between position and velocity and acceleration, which lines up with this exactly, which is great, okay? Okay, let us go ahead and pull up the homework that I handed you yesterday. I said we'd do a couple of problems. Not the graded one, not the graphs. We probably will grade that in the last class. But Cody, the procedure is going to be, I'm going to put the paperwork over here, so you can come over here and grab this. I have a copy of your quiz. You can ask Emily or someone else about quiz correction procedures. So it looks like I'm postponing today's lecture until tomorrow. And we're going to answer some questions on this assignment. So Chloe, you had a question. If you already have this assignment complete, you can work on something else quietly of your choice.
My question was like kind of like a big picture question. I just didn't know what exactly you were looking for.
Looking for the derivative.
Feels like.
Rosa, based on a question that you had earlier and a statement that I heard from someone else, I think it needs to be very clear. Y'all might want to add this to your notes. I don't think I clearly told y'all this, or I don't know, maybe I kind of like ran through it very quickly. The constant multiple rule. Okay. Let's say that you have f of x is equal to some constant, so some number, c, times blah, 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 blah. I don't care what it is. It could be x squared, it could be sine, it could be the square root of x. I don't care what the blah, blah, blah is, okay? But instead of writing blah, 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 because that's not very mathematical, I'm going to write g of x, okay? And what that means is some expression or function of x. The derivative then is that multiplier c times the derivative of g. So that's g prime of x. Example. If f of x equals 5 times x squared, the derivative is 5 times 2x to the first. Example, if h of x is 7 times sine x, h prime is 7 times the derivative of this function over here, cosine x. That's the constant multiple rule. It's called constant because this is a constant. It's called multiple because we're multiplying. And it's called a rule because it's a rule. So, in question number 1, it says differentiate each function with respect to x. Problems may contain constants a, b, and c. So 5 times c times x to the negative 1. So the derivative is going to be, I've got 5, which is a constant multiple, so that just drops down. C, which is a constant multiple, so that just drops down. Now what is the derivative class of x to the negative 1?
Negative 2x. No.
Give me negative 1, pop down. Take that, put it in, and then times
X
x
to the 0.
-2.
No, it's the negative 2. It's the
to
negative.
the negative 2. Pop down, power down. Take that
Oh, yeah.
exponent.
So that's gonna
Since
be
it's negative, it's just question.
Hold on, one question at a time here. Hector, you first.
So then once it pops down, it's just like, so since it was -1, it goes to -2.
You're talking about this part up here?
Yeah.
So yes, so once it pops down, then we found by experience, that's just me just telling you this, but we did this several times. We found that exponent decreases by 1, and -1 minus 1 equals -2, which is why it goes down. So we can simplify this to be -5c. If you want to put x to -2, that's fine. If you want to put it as -5c over x to the +2, that would be fine as well. I've got both answers on the homework. So now as a table, I want you to try number 2 if you haven't already. Once you get it, move on to the next problem, and the next problem, and the next problem after that. I'll give you 30 more seconds on number 2. Yeah, we'll do select problems throughout the time. Five is a constant multiple. Heads up, I didn't see a single right answer walking around. So 5 times
2A.
2a times x, and then what am I going to do with that 2a?
Subtract 1.
Subtract 1, which is
One, 8.
algebra 1 students. We can't combine those
It's 2A
terms. They
minus
are
1.
not alike. 2a minus 1. It's not 2a minus 1a. You can't combine
No.
those. They're not like terms. They don't have the same variable.
Where do you get the 1 from?
Oh, from the power down.
Ask Hector 5 minutes ago. You always take this number right here and subtract 1 from it. So 10a x to 2a minus 1. Don't beat yourself up. Everybody messes up on that.
Oh, you didn't see my answer?
Let's skip on down to number 5.
Ooh.
Where I will tell you one formula which will help you remember these things. Okay? Anytime you have the nth root of something, you can rewrite that as whatever's inside here to the 1 over n exponent.
Okay.
So for instance, you know, if you have the square root, you could write that as 9 to the 1/2. Since the square root has an implied 2. So what if you have x to the m on the inside?
You could write it as x to the
X to
over
the m.
m over
You could write it as x to the m to the 1 over n, right? Now, algebra 1, a power of a power. What do you do with those powers? You multiply them. So that's x to the m in the numerator, n in the denominator. I would expect you as calculus students to be able to go from that statement to that statement.
Yeah, I didn't realize.
Like so. That's why I'm doing it here. So y equals -1/3. So this is a rewrite situation, class. X to the what?
2 over 5.
2 over 5. So use some different notation here. So y prime is equal to, this -1/3 is a constant multiple, so it just stays out front. Times, pop down,
2/5. 2/5.
power down, 1/5. No.
No, 2/5 x. Oh, it's the 2/5 minus 1, which is 5. So it's -3/4. 3/5, yeah.
Not sure on that, your calculator can help you out. So fraction times fraction is gonna be negative 2/15, x to the negative 3/5. Bet you never had a weird answer like that before. Let's flip through the rest of this homework and find select problems of various types so that we can work them together. Taking all requests. What do y'all like? Had a request from Emily, we've had a request from
14.
Chloe. Stephanie, which one do you like?
14.
She likes 14. What in the world is this notation right here?
Ooh.
Fourth
Oh,
derivative.
that's what it is.
Give you 0.
Maybe.
Not.
You didn't get there's only 2.
F prime of x would be, call it out to me.
Negative 4x.
Second derivative,
Would be negative 4.
third derivative,
0. 0.
fourth derivative. Yep. Now you know what that notation is. Somebody else.
Can we get number 17?
You can earn number 7. Read the problem to us there, Hector.
We define this y equals negative x squared.
Read the instructions too.
Alright. For each problem, find the derivative of the function at the given value.
Find the derivative of the function at the given value. What does that mean?
Let me just
Plug
find
in
out.
2.
Whatever x value it tells you.
Right? At the x, okay, that means you have to find the derivative of that x value. Okay.
You find the derivative and you plug in the x value into the derivative.
That's exactly right. Find the derivative, and then you plug in the x value. And it is important that you do it in that order. Emily, why is it important that you do those operations in that order?
Because each time you do the derivative, you get different answers. Like if you plugged in the negative 2 into that, it's going to be different because the derivative is the slope of the tangent line at that point.
All of what you said is true, but it is not the answer to the question. You suggested a two-part process. Part 1, take derivative. Part 2, plug in negative 2, I would assume into what you get, right? What would happen if we were to reverse those steps?
You get like the point and not the slope.
No. So maybe kind of sort of. If you plugged in negative 2, what would that give you?
It would give you the derivative. No, it wouldn't.
If I plugged in negative 2 to this formula,
It would give you the y value.
The y.
the y value,
y value.
right? It would give you the y value, and then you took the derivative of that y value.
It would be a constant, right?
The y value is a constant,
The
so
y
it would
value
give you
is
0.
constant.
So if you plug in negative 2 and you get that y, you're just gonna get that y value, and then you take the derivative, it's gonna give you 0. It's gonna give you 0 every single time. See what I'm saying? So that's why it's very important that we don't do that, the reverse of this process. We first take the derivative. Now I might rewrite this, and I need to rewrite it. Y prime is pop down to 2. Can you handle that? And then that cancels out this 2, so it just becomes negative x to the first. And then minus 2. Negative. You okay with that? And then plug in negative 2 here. So negative 2. Oh my gosh, are you serious? We got 0 anyway? Sure, surely that's not gonna happen with all these other ones. Let's try it out on 18. What if we take the derivative? Call it out to me, class. What is dy over dx?
Negative 2 plus 6.
Negative 2x plus
Yeah.
6. Okay. And then we will plug in. So that's the formula for finding the slope at any particular x value. Over here, find the slope. And then plugging in x equals 1, it's going to give us negative 2 times 1 plus 6. So negative 2 plus 6, 4. Let me introduce you to some notation here that I have not shown you. Dy over dx, straight vertical bar. It means evaluated at x equals 1 is equal to 4. So when mathematicians say, we want you to plug in this value, then they draw a straight vertical bar. So the derivative evaluated at x equals 1 is 4. You can do 23. So what's the, read the, is this the same instructions or different instructions? Oh, 17, 18, 19, 20 said find the derivative of the function at the given value, but this one says what, Chloe? Find the slope of the function at the given value.
Did we do an extra step?
Well, what's the difference between finding the derivative at a value and finding the slope of a function at a value? Anybody know?
Wait, what happened?
Let me ask you this question again. What is the difference between finding the derivative of the function at a value and finding the slope of the function at a value? Just have a little more confidence, Jeremy. Say it out loud. It's the same thing. How many times have I said it? What's the derivative? And y'all say it's the slope. It's the slope of the tangent line. So there is no extra steps. It's just a test to see if you understand what those directions mean and if they meet. What about what now?
12. There are like 6 variables in that.
12?
Well, okay, I may have. Yeah, 12. How do we do that?
d4y over dx to the fourth. That is the notation for finding the fourth derivative. You're talking about number 12? D4? That, remember how I had all the 4 different notations? Unfortunately, this is on me. I did not show you the notation for the second derivative, for the third derivative, for the fourth derivative,
right.
of all those. I can show those to you now. F prime, F double prime, F triple prime, Y prime, Y double prime. So, Rosa, since you were asking about this, dy over dx, the second derivative is d2y over dx2, d3y over dx3. You get the point there. So when you see d4y dx4, then you know that that's asking for the fourth derivative.
Can you do an example of the last group?
Find, no, but I can point you in the right direction. Whoops. Find the equation of the line tangent to the function at the given point. Your answer should be in slope-intercept form. So, is it, looking at 28 here, somebody tell me, how do we build an equation?
You find the slope,
Find the slope
and then
and
you find the y-intercept by using the slope, point slope formula.
you could do that but you could also just use the point slope form and plug in some values. Does anybody know the point slope form or the point slop form?
No, that's not.
Nope.
Y minus Y1 equals,
M parentheses X minus X1.
yeah,
There we go. Do you have a Y1?
yes.
Yep. Do you have an X1?
Mm-hmm.
Yep, we've got a point. So we've got this, we've got this. Do we have a slope? Now we want the slope of the tangent line. How are we gonna find the slope of the tangent line?
Finding the derivative.
Find the derivative, plug in that x value. So the slope here is going to be dy over dx. Evaluate it, your notation, at x equals -2. So this is literally the same thing, but there's a third step. So you will need to find the derivative, plug in your x value, and then that will give you the slope. You can then take these values, put them in the point slope form, and then manipulate it to y equals mx plus b. There's some things I'm okay not giving you full crazy examples, and this is one of those things. We did, if you want to, you look in your notes, we did find the equation of the tangent line last week. So you've got paper evidence as well as video evidence. See you tomorrow.